In this section, we're going to start talking about solving systems of linear equations. And when we solve a system of linear equations, what we're doing is solving multiple equations and multiple variables simultaneously. And when we say we're solving a system of equations that's 2 by 2, that means we're solving two equations with two unknowns. Now, there are different situations you can run into when you're solving a system of linear equations. You could have the typical situation. This is usually what happens, where I have two equations. We'll call this y1, and I have another equation. We'll call this y2. We have two linear equations, and where they cross would be the solution. The solution is going to be an ordered pair. So this point here, xy, whatever that point is there, is going to be your solution to that system of equations. So that is the first possibility. The second possibility, if I have two lines, we'll call it y1 and y2. Because the solution is the x and the y coordinate that work for both lines, the point of intersection is going to be the solution. Now, if there is no point of intersection, then there's no solution. So in the case where you have parallel lines, this is going to be a special case of no solution because they never cross. Then the last special case that we have, so this is a special case, and then this is a special case. If I have a line, y1, and then my second line has the same slope and the same y-intercept, it's going to be the same line. They're going to lie right on top of each other. So y1 and y2 will be the same line. When the two lines lie right on top of each other, what's going to happen is they intersect everywhere. So every x, y point that works on one line is going to work on the other line. So all points x, y that work for one line will work for the other. This is called infinite solutions. This is called infinite solutions because any point that lies on this line will work for both lines. So any of those points on that line, so there's infinite number of solutions. To determine if a ordered pair is a solution to a system of equations, it's got to work in both lines. Remember, it's where the two lines cross. It's an x and a y that works for both lines. So when I plug in an x and a y to see if it works for that system of equations, it has to work for both lines in order to be considered a solution for the system. So if I call this line 1 and I call this line 2, let's check line 1 first. I'm going to put in the 3 and the negative 2 in for my x and y for line 1. So I'm going to put in 5 times 3 plus 5 times negative 2 is equal to 5. This gives me 15 plus a negative 10 is equal to 5. 15 minus 10 is 5, so it works. Now I can't stop there and say, oh, it's a solution. It's a solution for the first line. In order for it to be considered for the whole system of equations, it's got to work for both equations. So now I have to check it in equation 2. So I'm going to plug in 3 for x and -2 for y. So this gives me 15 plus a -2 is equal to 13. So it works for the second line as well. Because it works for both lines, we would say this is a solution to this system of equations. Okay, example 2, we're going to do the same thing again. I'll call this line number 1 and this line number 2. And it's asking us to determine whether 0, 1 is the solution to the system. And I got to check 0, 1 into both lines. So if we check line number 1 first, I'm going to plug in 0 for x and 1 for y. So I have 5 times 0 plus 5 times 1 is equal to 5. So this gives me 0 plus 5 is equal to 5. So this works. So it works for that specific equation. In order to say that it works for the entire system of equations, it's got to work for both equations. So I'm going to check it in equation number 2. So now I'm going to plug in 0 for x and 1 for y in equation number 2. So I have 5 times 0 plus 1 is equal to 13. This gives me 0 plus 1 is equal to 13. This does not work for the second equation. So I cannot say that this is a solution to the system of equations. So keep in mind when you're checking to see if something is a solution or not, you want to make sure it works for both lines. Now in the case when we go on later and do a 3x3 system of equations, we want to make sure that it works for all 3 equations. But in any case, you want to make sure that it works for every equation in the system. And then the solution is going to be where all the lines cross. It's going to be the intersection.